So now we're going to finish up with chapter 12. 12.7 takes us into something that I mentioned a couple videos ago, but also then applies the past couple days that we've done. So I mentioned something a couple videos ago. I said, so this would be identified as an outlier, but we would talk about that here in the next couple lessons. Well, this is the lesson we're going to talk about outliers in. So our goal for this lesson is to understand two different pieces. Number one, what an outlier is and how I identify it. But then, how does that affect my median, which we talked about in the last lesson with mean, median, mode, plus the range. And how does it affect my mean, or my average, which we've done for the past couple of lessons. So just a quick review. The mean means average. I find all the pieces of the data, add them together for my sum, and then I divide by how many are there. That's going to give me my average, or my mean, or my share-fair balance, which we learned a couple of lessons ago. How is it also going to affect my median, that middle number? And once again, when I find the middle number, I have them all in order from least to greatest. If there's an odd grouping of data, then it's the center one, and that's pretty easy. If there's an even grouping of data, if there are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 of them, so on and so forth, then I know I have to find the middle two, add them together, and divide by 2, since I'm using 2 of them. Now, if I group them together and it's the same number, I don't have to do that math because they're the same number and the median would be identified. We want to know what the outlier is and then how that would affect those two pieces of information when it comes to my data. Let's look at what the definition in the book says that an outlier is. The book says it's a value that is much less or much greater than the other values. So when I look at my heavyweights pinning times over the season, he had mostly within the first 2 minutes where he pinned his guy. A couple of them he won at the end of 4 minutes because he went the entire wrestling match. But on Saturday, he pinned one guy in 14 seconds. That was an outlier. It was faster than what he normally does because normally he's within the first 2 minutes or takes the entire 4 minutes. So he had his average range of when he won his matches, but the outlier was much less. It was a much quicker pin in 14 seconds. It was pretty impressive to see. You may see people like at recess or when your family gets together where you have somebody that's just off on their own. That would be considered an outlier of the group. When it comes to data numerically, it's any number that's not with the grouping of the rest of the data. Now, we'll see that the book gives us an option of having one or multiple outliers. I could have 2 numbers that are way over here, away from the data group, and I could have 2 outliers. I could have 2 that are way far behind, and that would be 2 outliers. I could have one that's way over here that's less, and way over here that's greater, and also have 2 outliers. But I will tell you in all these practice problems that we have, there is only one that they give you the, in parentheses, the S, showing you that we could have more than one as an answer. So we start with the data chart, the data that we're collecting. And on this data, we're talking about a volleyball team, and they're just looking at how many days of school they missed as a group. When we look at the data chart then, we see what it tells us to use. It says to plot the data on the number line. Now that's a lot of points. And when you keep track, once again, I would strongly suggest you cross it out each time you get ready to put one down. That way, you don't lose where you are. Now, I understand that it's going to take a couple moments for you to plot all those pieces of information. After all, there's 8 going across and 3 down, so there's 24 different dots that we have to do. Please understand, when I ask you to do it, I've already done it on the computer and it takes me longer than doing it with a pencil. I have to insert the image and then I have to add the transition so it's done. It took me quite a bit to put these 24 markers in here, so please just take the time to do it. If I go too fast for you, then you have that magic pause button to pause the video, get caught up, and be able to do it. But once again, on the videos, it's important that we're paying attention. Yes, I understand that I asked you if you watched it. Yes, it was playing, but I was thinking about something else, or I was talking to my friends, or I was working on science, but it played. But you're not learning from it. The idea is that you're participating, you're filling in your book, you're learning from it as I'm explaining it. And this is just you and I then, as you're watching it, compared to 23 other people who may be talking and distracting you. This allows you to focus. This is why I've done it for almost 100 lessons now. So as we go through it then, we go piece by piece. I have a 4, and I'm going to plot it on my line. I have a 6, I'm going to plot it on my line. I have a 5, I'm going to plot it on my line. Once again, you don't have to cross them off, but I would suggest that you do, and don't count it wrong if you don't mark them off, but it helps you keep track of where you are. We're going to get a point for showing this work though. That's where the point comes in, because you completed the first step, which is to create your dot plot line. In my second column then I have a 6 and I plot it, a 7 and I plot it, and a 6 and I plot it. And then I go to my third column. I have a 7 and I plot it, a 3 and I plot it, a 5 and I plot it. I go to the fourth row, almost halfway done now. A 4 and I plot it, the 5, the 7, then I get past the halfway mark, 5, 8, and 6, 5, 8, 6. A 5, a 6 was 16. Well, I'm pretty sure I know what my outlier is. And a 4, 5, a 16, and a 4. And then I have a 3, 5, 5, 3, 5, 5, and a 6, 4, 4. I plot the 6, I plot the 4, I plot the 4. I've created my dot plot line, which is step number 1. I get credit if it's done and correct. Then I have questions right below, but I have it on a separate section because I wanted it big enough for you to be able to see it on the computer screen. Now it says to find the values that are much greater or much less than the other values. So then we fill in the information. It says most of the data values are between what and what. So when I look at my dot plot line, I can see the information now displayed in a way that I can quickly interpret it. So most of the data is right there, between the 3 and the 8. So that has to be those answers. Well, if that's the case, then what is the outlier? Well, as I said when we were applying, it became pretty obvious as all these other numbers were below 10, and suddenly I had a 16. So 16 has to be the outlier. So identifying the outlier is our first goal of this lesson, but the second goal then is to know how it's going to affect my other data that I collect with this information. How's it going to affect the mean, or how's it going to affect the median when I have that outlier in it? This question then says to explain. What effect do you think an outlier greater than the other data would have on the mean of the data set? And then you're going to justify your answer. And I have some of you on the most recent lessons in chapter 12, you're just putting a math problem here. The math problem is the second part of the question. You get a point for the justification. But if all I have is a math problem, I can't give you credit for explaining something because you're not giving me any words. And if I don't have words, if I don't have an explanation or a description of it, then I can't give you credit for it. When I look at how that is going to affect it though, I know what we're talking about, the mean, and the mean is by adding all of them together and then dividing by how many are there. So I wrote, since the mean is based on the total sum, followed by division, the mean would end up higher because 16 would raise the total sum. Meaning that if all of this information is less than 10, and then I suddenly added a 16 to it, my value is going to be higher than your average number would be in the group. So I know that my mean overall has to be higher. Can I prove that? Can I justify that? Sure I can. I can do 2 math problems. And that's what this lesson is about, is showing 2 different math problems to show how the mean is affected. Or 2 different math problems to show how the median is affected. Since we're talking about the mean, I have to find 2 means. I have to find the mean with the outlier, and I have to find the mean without the outlier for just the main part of the group, and see if it truly is going to raise it up. So I would have to go in with my handy dandy calculator, and I would have to add all of those together. 24 numbers, and then 23 numbers. But I was nice, and I did it for you. So when I justify my answer, then I do my math. So I'm telling you right now, with the 24 numbers, I get a total of 136. for the 24 numbers. When I take the outlier off, I have 23 numbers, but I have a total of 120. So now I'm going to look at what that mean would be. And how do I do the mean? Well, I found my total, and then I'm going to divide, right? Because it's followed by division. So I'm going to divide each of those out and see what my mean ends up as. With my outlier, I see that my mean is 5.7 or 5 7/10. With the outlier, excuse me. Without the outlier, then I have 5 2/10, 5.2. Am I proving then that my thought that it would raise my mean or raise my average is correct? It is. It is 0.5 or 5/10 higher than without the outlier. So I proved myself correct. Well, let's look at the second example that they give us then. Talk about temperatures now. It says the high temperatures for the week in Foxdale is in degrees of Fahrenheit were 43, 43, 45, 42, 26, 43, and 45. The mean of the data is 41 degrees, and the median is 43 degrees. Identify the outlier and describe how the mean and the median are affected by it. Draw, step 1, a dot plot of the data and identify the outliers. That's going to be my first step. So I have to plot my information. I have 43, I plotted. A 43 again, I plotted. A 45, and I plotted. A 42, and I plotted. A 26, so we had a cold day there. And then we're back to 43, and then 45. So just a tangent thought, if I was doing this, with this dot plot line, I can quickly see what my mode of the group would be. The one that's there the most often was 43 degrees. Now, that's not one of the questions, but just a review of what we talked about yesterday. So the outlier is which one then? Pretty obvious. This really cold day, 26 degrees Fahrenheit. With that information then, we go to the next one. Find the mean and the median of the temperatures without the outlier. So without the outlier, I have to, once again on mean, I have to add them together. But I'm getting rid of the 26 because I'm doing it without. So when I get rid of the 26, I'm just doing the 43, 43, 45, 42, 43, 45. That was the order they were listed in the story problem. And I'm dividing by 6 now instead of the 7 days of the week. So when I take their total on my handy-dandy calculator and I add them together, I would get 261. And when I take 261 divided by 6, that gives me 43.5 degrees. Then when I look at the median, I have to have them in order. So you could have started by listing these in order as you were doing that one, and then finding the median from the same data set. It's not the way the book did it, so I just followed their lead. So I put them in order. I should have my 42 first, my 3 43s, followed by 2 45s. And when I look at the median, I have 2 numbers in the middle that I have to look at. Why do I have to use 2 numbers in the middle? Well, because there are 6 pieces of data there. And when there's an even number, and I cross off from left to right, left to right, left to right, I end up with 2 in the middle. So I focus in on a 43. Now, when we did median, we talked about finding the middle number of an even number of data. Then we said we had to add them together and divide by 2, because there were 2 numbers we added together. However, this one's easy, just like one of your homework assignments last night. If it's the same number that's in the middle, then my median wouldn't change if I add it. I could add it together and I would get 86, but 86 divided by the 2 is still 43. So it doesn't change it, so it's just 43. So then, if I look at the information, the mean with the outlier is what? Well, the mean with the outlier, I skipped ahead, I apologize. So I have to find there it is, with the outlier. So the mean was 261 without the outlier. If I add that together with the 26 that I eliminated, I'd have 287. So there was not 6 this time. I added that 7th one back. 287 divided by 7 gives me 41. In the story problem, that's what it said. But I'm just showing you how they got the 41. So when I add them all together, once again, the 261 was when I added just the 6 together. So if I add the extra one, the outlier, I get 287. And then instead of dividing by 6, I added the outlier, so I would divide by 7. So I got 41. So with the outlier, I know that my mean is going to be 41 degrees. The mean without the outlier is what? Well, without the outlier, we said it's 43.5 degrees. The outlier did what to the mean? Well, it lowered it. And that should make some logical sense. If all of these days were up here in the 40s, and then I had one cold day that I include in my data, then that's going to lower because the amount that I have should be lowered by this much smaller outlier. So I should see that it does indeed lower it between 43.5 down back to the actual mean of 41. So the outlier did make the mean lower. Well, what about the median? So when we looked at the median of the original group, then it told us that it was 43. And the way they got that is they just listed them in order from 26, the 42, 3 43s, and 2 45s, and we went from end to end until we found in the middle, because there were 7 numbers, which is odd, that the middle number was 43. When I do it with this data information, I see that I have 2 43s. It's the same number. Once again, I could divide by the 40, but by the 2 if I added them together. But instead, since it's the same number, I know it's just 43. So what was the effect on from the outlier on the median? Wasn't effect at all, was there? It just stays the same. So it does not affect the median. So it goes back to the idea of the mode. If there's not a mode, we just put no mode. If there's not an effect on one of these, then we're just going to put it does not affect it, or no effect. Going on then. Thinking about and working through it. Explain why the mean without the outlier could be a better description of the data set than the mean with the outlier. So, let's say in science, your average scores on your test would come out to a 96%. However, on one of them, you totally forgot to study. You thought that you learned enough by listening to me or watching the videos or doing the assignments. You really didn't need to study. You did use a study guide, and then you sat down and you got a 47. Would you be happy by telling mom and dad what your average was, using that 47 in there, or would it be a better idea of how you'd really do on your science test by eliminating that 47 from the data collection and just using those high 90s, maybe a high 80? You know, it would make more sense. So when I explain why using that average, I have to understand what it does to it. When the outlier is lower than the rest of the data, then it lowers your mean further than it should be. You don't actually get an average of 78% on your test, even though that really low 47 affects your 95, 96 average. So if we eliminate that, just say, well, I had one really bad day, but all my other tests, mom, dad, are 95% average. That's more accurate of what you're doing in class. You know, we don't want to look at it and think, holy cow, you know, we're doing really bad. I only get a C average. No, you actually get an A average. We just had one really bad day, some bad choices. So when I look at the question 3 then, the second one on here, if the outlier had been 59 degrees Fahrenheit rather than 26 degrees Fahrenheit, how would the mean have affected by the outlier? Explain your reason. So what that's saying is back here to this information. If my mean or my outlier was instead of here, but it was over here, we saw that a lower temperature lowered everything when it came to the mean, but not the median. How would it change if my outlier was hotter? Well, it would have to raise it, wouldn't it? So when I look at it, 59 is greater than the rest of the data, so it would have to raise my mean value. Maybe you normally get 84s, 85s on your science test, but one day you studied your study guide some extra amount of time and you put forth some extra effort and you got 100% on it. And now that raised your average to a 91%. And you can tell mom and dad, well, I have a 91% average on my science tests. It's pretty impressive compared to an 85%. 85 is still good, don't get me wrong. B's, I was always happy with B's. Very seldom got them, unfortunately, when it came to reading. So, looking at the practice problems that we're going to work together. Find the outlier by drawing the dot plot of the data. So I have to start by making my dot plot line. So when I look at it, I have some numbers that are repeating multiple times, right? So another way, instead of going one by one by one by one, is just looking at my lowest number is what? It's 1, and how many 1s do I have? 1, 2, 3, 4. I have 4 of them, so then I can plot the 4. Do I have any 2s? Yep. 1, 2, 3, 4. I have 4 of those, so I plot the 2s. Do I have any 3s? Yep. 1, 2, 3, 4 of those. So I plot those. Do I have any 4s? Nope. How about 5s? I do. I have 1, 5. I didn't plot it. Somehow I skipped that, but the same answer I'm going to get to, though. My outlier is all by itself. It's a 15. Where did that come from? Well, the foul shots that were made, I had a really lucky game, I would say, and I got 15 of them. I would be terrible at that. Most of mine would be 0s and 1s. Yeah. So by identifying my outlier, though, as the 15, because it's the largest number in the group. When I look at number 2, then it says the prices of the X40 laser printer at 5 different stores are $99, $68, $98, $105, and $90. It says the mean price is $92 and the median price is $98. We'll show you how we got that in just a moment. Identify the outlier and describe how the mean and the median are affected by it. Now, on your homework, if it gives you that information, I don't need you to show me how they got it because we would rely on their information. But I'm going to show you, just to remind you, because it's extra practice on how they got that information. But I have 5 pieces of information because it says 5 different stores. They are listed there. So I have to look at what we're talking about, and I always put them in order so my median becomes a lot easier. And I also find, personally, doing my adding on my calculator a lot easier than trying to keep track of different numbers. So first I want to start by figuring out what my outlier is. Well, all of these are between 90 and the low 100s except for the 68. So that's a quick identification. That's the lowest price. Maybe it was on sale or something. The $68 has to be my outlier for this piece of information. When I look at having all of these together, though, and I look at how we got the mean, once again, mean means average, so I add them all together and then divide by how many is there. When I talk about the median, we're talking about finding the middle of that information. And there's an odd number, so I would just pick the middle number. So when I add them all together, I get 458. There are 5 there. So when I divide out, I get 91.6. So that would be $91.60 as a mean or as an average. When I take the outlier out then, and I look at what happens, well, instead I have 4 pieces of information, and I add those together, now I have 390, because that's the biggest amount of groupings. The outlier, what did it do to it? Well, the outlier was so much lower, so that would have to have changed the mean. Well, to prove it then, I take the 390, and this time I want to divide by 4, because I removed the outlier, and 390 divided by 4 is $95. So the difference is between $95 and $91.60. It does affect the mean by almost $4. So when I look at what it is without the outlier, it's $95. And we know that the story problem tells me that with the outlier, the mean price is 92. Now, where did they get the 92? Because we divided, we got 91.6. Well, they just rounded. Well, you could just round to the nearest whole number, and a lot of times that's what you're going to do with data. Instead of going out all these decimal spaces, we just round to the nearest whole number, or scientifically, we usually go to the first decimal position. So it would round up to 92, so they're not too far off as far as the information they provide for you. When we talk about the median then, we look at the middle. And here I have two different numbers that are different, right? Different numbers. So 99 and 98, I would have to add those together, and then I would have to divide by 2. Well, right in the middle, since they're only one step away, 98 and 99, if I don't add them together and I just think logically on the number line, what would have to be between those two numbers? Well, it's 98.5. It's right in the middle of 98 and 99. So when I look at my median without the outlier, it's 98.5, and they tell me that it's actually 98 with it, and I got 98 as well. So how did that affect it? Between 91.6 and 95, and 98 to 98.5. Well, the outlier lowers the mean, and it also lowers the median. All right, question 3. Identify the outlier. Now, I paused for a moment, but if it wasn't enough time, pause your video before moving on so you get that written down. Identify the outlier in the data set. So my data set's over here. Then describe the effect the outlier has on the mean and median. So where's the dot plot that I need to fill in? It's not there, is it? I don't have to do the dot plot on this question because it doesn't tell me to. Could you draw a dot plot and fill it in if that helps you? Absolutely, by all means. Show your work in that way if you'd like. I just like to list my numbers in order from least to greatest. I put my 14, then I have 3 45s, followed by a 46, 3 47s, a 48, a 49, and then the 51. Once I have them in order, then I can quickly identify, I could just look at that chart and identify also, that my outlier has to be 14 because everything else is from 45 and up. 14 is way off. So I'd have to say that my outlier is the 14 ounces. But then it says to then describe the effects that the outlier has on the mean and the median. Now I could do my work to show it, but I could logically think, okay, well, since the outlier is lower in number, it's got to lower my mean. So then the mean would be lower. The median, however, not as easy to figure out, is it? Okay? So I know that it's definitely going to lower it, but the mean doesn't necessarily have to be lower or raised if it was a higher number. So we have to look at it. I could have no change at all. When I look at the actual median then, and I identify all of the pieces of information I have, it's a bigger group, but I can go back and forth until I get to the middle number because there was an odd number of pieces of data. So I see that 47 is my median of my original group. Well, if I know it's 47 and I keep that there, what happens if I drop my outlier? Well, if I drop the outlier, then I have an even number of pieces of data. So I have to find the middle 2. And when I do that, I have 1, 2, 3, 4, I cross them off. So I go over there and cross off 4. And then my middle 2 is, they're both 47. And we said with it, it's 47. And without it, it shows it's 47. So the median, it does not change. There's no effect on my median. And that's okay. There doesn't have to be. But I've proved what took place. All right, so then we have the problem solving, and we're dealing with baseball. I'm going to say, because of coloring, it's older baseball and by the uniforms. But it asks which player's number of stolen bases is an outlier. So we have 5 different individuals who played baseball. Ty Cobb, for me, was the most popular one that I know. I don't know the other players, but I'm not a big baseball follower. I am sure my oldest son would know every one of those and be able to quote most of their statistics. But when I look at what the outlier is in stolen bases, well then Ricky Henderson has a much greater amount compared to everyone else. About 500 more stolen bases in his time than anyone else has had. So I know that Ricky Henderson is my outlier. He's the one that overdid everyone else. Or maybe there was an individual that underperformed and that could have been an outlier as well. But then when I look at it, we want to see how Ricky's stolen base number affects everyone else's. What effect does the outlier have on the median of the data set? So I have to look. When I go back to my original data set, my median is right in the middle. I have 5 players, so the middle person is going to be my median. So Billy Hamilton is at 914. That would be the median of the original 5 group. However, Without the outlier, let's see what it would be. So I get rid of Ricky Henderson, and I only use those 4 scores that there are. And when I have only 4, then I know that that's an even number. I have to choose the middle 2 amounts. And how do I find the median of 2 numbers? I add them together, and I divide by 2. So when I add them together, I get 1,811 stolen bases. And when I divide by 2, then my median becomes 905.5, or 905.5 stolen bases. But the question is, well, what effect does it have on it? Well, with Ricky Henderson, my mean was 914. Without Ricky Henderson, that was way up there, then my mean actually drops back a little bit. It's actually a lower amount. So with the outlier, the median is 914. Without the outlier, it would be 905.5. So how does it affect it? It raises it up above what it would have been without it. It's a higher number, so it does raise the median. Won't always be the case, because as we saw in the previous one, there wasn't any effect on the median at all. Sometimes there is. Alright, so that ends our review questions that we're going to do together. Hopefully you followed along. Yes, it's a longer video, but it's simply because there's a lot of things to cover, and I reviewed several things that you know is going to be on your test tomorrow. Your assignment is very short, though, compared to your other ones. You have 2 through 4, and you have 1 through 6. So you should be able to get it done rather quickly. You just have to take your time, do all of the steps in the problem, show all of your work, and make sure you answer all of the pieces. If it asks you to explain or to describe, you have to use words. If it asks you to support it, then that's where you show your math. If it asks for both, then you have to do both. You have to show words and you have to show numbers. As you work through it then, if you have questions, you may come and ask.